Biological materials have the fascinating ability to adapt their structure to the demands of the environment. Structural adaptation occurs on very different timescales: the evolutionary timescale and the much shorter timescale of the lifetime of the organism. An important example of structural adaptation, where the result of the adaptation is recorded in a robust material, is bone. Looking at the upper femur of different primates, one can observe that not only the overall shape, but also the inner foam-like architecture is different. Bone structure is not only shaped by evolution, but also how the animals load their bones, that is, by their way of locomotion. Beside our interest in how bone adaptation to mechanical loading is controlled, we ask questions with a more philosophical touch, for example, concerning the spatial and temporal defining boundary of structural adaptation. First, is structural adaptation spatially limited by the physical boundary of the organism? Here, our thinking is influenced by the concept of the extended organism by Scott Turner. Second, is structural adaptation limited to the lifetime of the organism? Seed dispersal in plants provide examples in which only that material still undergoes evolutionary adaptation. More information about this example you find under the info point of the banks here. Questions like these are discussed in the excellence cluster between natural scientists, philosophers, cultural scientists and designers in the context of a more comprehensive framing of the activity of materials.